Okay, welcome to Level 1 Science Online with Henny van Vuren.
Welcome back. I hope you had a good break and that you caught up with all your mates. You need to stay in contact. Don't be isolated, okay? It's very important during this time, but no physical contact and keep your social distance. Anyway, so describe the motion of the runner through section A, B, C, and D. Now, remember, this is a speed time graph. Your answers should include descriptions and calculations. So, section A, my speed went from 0 all the way up to 10 and it took me 8 seconds. So what do you think that is if it's a straight line and my speed went up? It means a constant acceleration. Okay, so constant acceleration. Now we can actually then, so the first thing we're going to say is A is a constant acceleration. And it's positive because it's going up. And then we can actually show them the calculation. So we can have 10, remember, because acceleration is our change in velocity over change in time, which is velocity final minus velocity initial divided by time final minus time initial. Now in both these cases, velocity initial was 0 and time initial was 0. We know that it's going to be positive because it's going upwards. So we have velocity final in this case is going to be 10 meters per second divided by time, which was 8 seconds. Okay, and now the handy dandy calculator. We have 10 divided by 8. Okay, and that's 1.25 meters per second per second. Okay, so that was section A. Now during section B, 10 meters a second at the beginning, and that's velocity initial, and velocity final was 10 meters a second. Was there any change in the velocity? No. So section B is constant velocity. Okay, so there's no acceleration, no forces. So forces are balanced. Alrighty, then now we're going down at a pace. Section C, we go from 10 down to 0. It takes us 20 minus 15 seconds. So, oopsie. I'm still getting used to this, guys. So please bear with me. I wonder what this is, but anyways. So section C, we know that it is constant deceleration. Okay, and deceleration means negative acceleration. So we go, acceleration is change in velocity over change in time. Our v final minus v initial divided by time final minus time initial. So velocity final was 0, wasn't it? Minus, and where did we start? We started at 10. Divided by our time final was 20, and our time initial was was 5. So 10, which basically then gives us minus 10, 15, minus 10 over 5, which gives us negative 2 meters per second per second. Okay. Sorry, you can't see that. Anyways, so let's check what the model answer says. And you can see here, section A, basically 1.25, like we said. and then section B was stationary, or not stationary, constant speed. Section C was decelerating, so minus 2 meters per second. Now, do you see that the person is not showing calculations, they're simply giving answers? So this would have been merit and not excellence, because you need to show your calculations. Okay, they ask you for calculations, show calculations. Alrighty, here we have the kereru. Let's have a koreru about the kereru. Koreru means talk, kereru is the wood pigeon. So, the speed time graph. So again, we have speed time graph, the flight of two birds. Use the graph to explain which bird has the greater acceleration in the first 3 seconds. Greater acceleration simply means steeper curve, steeper gradient. So which one of the two? Is that bird B or bird A? It's easy, it's bird B, but we can support that with calculations, because bird B goes to, as you can see here, 3 seconds to get up to 9 meters per second. So for bird B, we will say that the acceleration is the change in velocity over change in time equals velocity final minus velocity initial divided by time final minus time initial gives us velocity final is 8, 9. Velocity final is 9 minus 0, so I'll just put in there 9 meters per second, divided by time initial was 0, so time final was 3 seconds. So there we go, 3 seconds. So our answer for bird A is 9 divided by 3 is easy, 3 meters per second per second. Now for bird A, it went from 0 to, and look carefully at the question, for the first 3 seconds. So it went from 0, and here's 3 seconds. It actually went to, that's probably about, what's that, 7.5 ish. So bird A's acceleration is change in velocity over change in time, which means velocity final minus velocity initial divided by time final minus time initial, which gives us, both of the initials are zeros. So bird A, the blue line, we have 7.5 meters per second divided by 3. And the handy dandy calculator, 7.5 divided by 3 equals 2.5. 2.5 meters per second minus 2. Okay, so we have supported our answer with calculations. Easy. Okay. There's the model answer. 2.5 for bird A and 3 for bird B, and the gradient is higher for the first bird. Awesome. Okay, then 2016 question 2C, still talking about the birds. In 16 seconds, bird B traveled 121 meters. How much further did bird A travel in the same time? So we're at 16 seconds. Okay, bird A traveled 121. So what do they give us? They gave us time, and they gave us distance. Alright, so how much further did bird A travel? Now, when we want to talk about distance, whenever we're talking about a speed time graph, this I haven't shown you yet, we have to work out the area under the triangles. So let's just, for now, I wonder how I change my color of my pen. So here we go, bird A. Okay, so you have to calculate the distance, the area under the graph. So for bird A, it's going to be this triangle here. And then this triangle here. Okay, and then this rectangle in the middle. Alright, so I'm hoping you all can see what I'm doing here. Forget about the red line. So we have a triangle and a triangle and a rectangle. Now, a triangle is to calculate the area of a triangle. It's quite simple. It is, you basically have the base, half times the base times the height. Okay, so in this case, half of our base over here for section A, so we put down an A, and then we say half times base times height. Because the triangle, when you think about it, a rectangle is base times height. But a triangle is exactly half of that. So this part can go away. That means it's half base times height. Got that? Okay. Something strange is going on here. I've got closed captions. Okay, so my base is from 4 to 0. So half times 4. Okay, and my height is 10. Oh, that doesn't matter. Times 10. Okay, so 2 times 10, it works out to basically 20 meters. That's for section A, but the total path that he flew was A plus B plus C. Okay, so now section B, not bird B, section B, we go for a rectangle, it is base times height. So from 4 up to 14, and it's still 10. So the base is 14 minus 4 gives us 10 divided by, and our height was 10. Why am I dividing? It's multiplication. 10 times 10 gives me 100 meters. And then in section C, we do the triangle again. Half times base times height, so half times my base, 16 minus 14, so that's half times 2 times the height, which was 10. So that is becomes 1 times 10 is 10. Then we add these together. A plus B plus C. So 20 plus 100 plus 10 equals 130 meters. Now the question said, in 16 seconds, bird B traveled 121.5. How much further did bird A travel? Show all your working. So, you then say 130 minus, so therefore 130 minus 121.5 gives us 8.5 meters. Therefore, bird A traveled 8.5 meters further in 16 seconds. Okay, it's not that complicated, it's just a few steps that you need to remember. Okay, so you always take the, let me just see if I can get a wider, so if I take my highlighter and I change that, for instance, here, and I say there's my first triangle, here's my last triangle, and then the area in the middle is basically a rectangle. Does that make sense? I really hope so. And that's the end of today's lesson, so please complete SciPad page 22 and 23. Thank you.